Logarithmic function. In this video, we want to introduce logarithmic functions, and we learn about how we can evaluate them and how we can graph these functions. Logarithmic function is the inverse of an exponential function. And because of that, we can always convert a logarithmic function to an exponential form. They are always equal to each other. You can convert exponential to logarithm, can convert log to the exponential. But how do we read this one? To read this term, we say y equals log base b of x. Or we can read it as a log of x base b. So as you hear, we say base b. So the number, the small number that's under the log is called the base. So when we have the log x base b, this base, that's exactly the base when we convert it to exponential function. So if you have y equal log x base b, and you want to convert to the exponential form, you have to start with the base, and the base is b. And after starting with the base, you need to go in a zigzag direction. So b going to the left and back to the right. So b to the y power must be equal to x. And this is how we convert a logarithm to an exponential form. We always start with the base, because when we are reading an exponential term, also we always start with the base. When you want to read this one, you say b to the y power is equal to x. So you start with the base. So we do the same when we are converting from the log. We start with the base of the log and go in a zigzag direction. And we can use this property to convert the log to exponential form in example 1. But before that, let me just tell you that when we have a logarithmic function, base must always be a positive number and not equal to 1. Because if I have in base 1, 1 to any power is just 1. 1 to the third power is 1. 1 to the fourth power is 1. So we don't have a different number. So we say that the base cannot be equal to 1, but it can be any other positive number. Now let's look at example 1. We want to convert this log to exponential form. Okay. So this is saying that 3 is equal to the log base 4 of 64, or log 64 base 4 is equal to 3. And how we convert it to exponential form, start with the base. Base is 4, so base is 4, and the zigzag direction. So 4 to the third power is equal to 64. And that is true, because 4 to the third power, or multiplying 4 by itself 3 times, is exactly 64. Whatever we are writing, it has to make sense. Next one, we want to convert it to exponential form. Start with the base, which is 3, and we say 3 to the negative 2 power is 1 over 9. And that is correct, because 3 to the second power is always 9. But we know every time we have a negative power, to change it to positive, we have to move the number to the denominator. So that's why 3 to the negative 2 power is 1 over 9. Now in example 2, we want to convert the exponent to logarithm. This time we have an exponential expression. How we can convert it to log? When they say convert to log, that means you want to say the log of what number with what base, and it's equal to what. So you have 3 places to fill. And when you are reading this exponential term, you say 2 to the third power. That means you start with the 2, you start with the base. So the base is 2, go in the zigzag direction, 2 to the third power is equal to 8. Which means the log base 2 of 8 is equal to 3. And if you want, you don't need to just leave a parenthesis. You can erase the parenthesis. This is how we write it in log form. Okay. For next one, we say the log. So the base is 10. So the base of the log is 10. 10 to the power of -2, which is equal to 1 over 100. Or we say the log of 100's base 10 is -2. How we can evaluate logarithm, how we can find the value for each logarithm. Again, to evaluate each logarithm, it's easier to convert it to the exponential form. We can, because when you want to evaluate a log, that means you want to find the power. The base is given to you, the answer is given to you, you want to just find the power. And if you convert it to exponential form, start with the base, you say 2 to what power is 32? What power of 32 is, what power of 2 is 32? How many times you multiply 2 by itself gives you 32? And the answer is 5. So the answer is 5. The log of 32 base 2 is 5. For next one, we say 5 to what power it's equal to 125. How many times you multiply 5 by itself, it gives you 125. We want to find the power for 5. How many times? 3 times. 5 times 5 times 5 is exactly 125. For next one, we start with the base and we say 3 to what power is 1 over 9. How many times we multiply 3 by itself? It gives us 1 over 9. So there's no way that you multiply 3 by itself to you get 1 over 9. But you may get 9 by multiplying 3 by itself 2 times. You know 3 to the second power is 9. But since we have a fraction, 3 wasn't a fraction, but 1 over 9 is a fraction. That means the power has been negative. That changed it to the fraction. So the answer is -2. Because 3 to the second power is 9, but -2 is 1 over 9. We have two logarithms, which are famous one. One of them is called the common logarithm. Common logarithm, or the logarithm that the base is always 10. And that is the exact logarithmic that every calculator has the key for that. If you look at your calculator, just the basic scientific calculators, you see that there is no place for you to put the base, which means the calculator only calculate base 10. And you don't see the base, what means the base is 10. Every time you see a log that they don't write the base, that means the base is 10. Another logarithm is called the natural logarithm. Natural logarithm is a logarithm with base e. E is a famous number. We talked about this one in another video for exponential terms. And every time the base of a logarithm is e, that is called the natural logarithm, and we show by ln of x. ln, or the natural log, it's a type of logarithm which the base is e. And if we look at this one, it says if y is equal to ln of x, ln of x means the log of x base e. And if you want to convert to the exponential form, you have to start with the base, and you say e to the y power is equal to x. Sometimes for some logarithm, we need to use calculator. There is no way that we can find the power, because when you are evaluating logarithm, that means you are finding the power. And sometimes there is no way that we know the power of a number because of the numbers that are given to us. So we have to use a calculator. For example, it says evaluate and round your answers to 4 decimal places. First, we want to find the log of 10,000. The log of 10,000, when there is no base, that means the base is 10. That means you want to find the log of 10,000 when the base is 10. You want to find the power for 10. You want to see 10 to what power is 10,000. We actually can do this one even without the calculator. If you want to use without calculator, you ask yourself how many times I multiply 10 by itself gives me 10,000. Since 10,000 has 4 zeros, so that means the power must be 4. Or you can use the calculator, because in the calculator we have a log key, which is the base 10. You just need to find the log of 10,000. Just type it in the calculator and get the answer, and you will see that the answer is 4. Next example, part B, we want to find the ln of 37. ln of 37 means the log of 37 base e. I don't know. I have no answers because I don't know e to what power is 37 for. So I have to use the calculator. And there is another key for ln, the natural log, and we can use that key and find the ln of 37. And the answer is 3.6109. If we round it to 4 decimal place, yeah, that's where we have to stop. Next one, we want to find the log of 52. Again, since there is no base, that means the base is 10. So we can use calculator and use the log key on the calculator and find the log of 52. And the answer is 1.7160. Rounded to 4 decimal place. Now let's